All right, so again, tough day today. Tough day today. We are going to continue solving trigonometric equations. It's now what's going to happen, though, is these trigonometric equations are going to be intertwined within linear equations right now, and then later today, quadratic equations. And I'm going to add in a few little mixes of things that can happen to you that can change things up. But we're going to start with example 1 here, where it says 5 sine theta plus 1 equals 0. Now, before, what we had when we were solving trigonometric equations is we just had sine theta equals something. So all I'm going to do at the beginning here is make that happen. And so to do that, I'm going to move my 1 over to the other side. So I have 5 sine theta is equal to -1. And then I'm going to divide both sides by 5. And so that I get sine theta equals -1/5. Now, the first thing, the negative sign, the sign on our ratio here is going to tell us, using the cast rule, where our possible answers are. All right, so I'm going to draw a couple grids here. All right, now, sine is negative. The ratio is negative. And so if sine ratio is negative, the only time that happens is in the third quadrant and the fourth quadrant. So the first one and the second one, those where our answers are not going to be there. All right, so this is kind of a little review now of what we did the last week. But now I'm going to take the sine inverse of 1/5. Not -1/5, but 1/5. And that will tell me what my acute angle is. And so if I take the sine inverse of 1/5, I get, let's see here, sine inverse of 1/5, I get 0.2. So that tells me what my acute angle is. And so that means if it's in the third quadrant, again, your acute angle is the angle between the smallest angle between your terminal arm and the nearest x-axis. So right here, and we have 0.2 radians for our angle right in there is our acute. And in the fourth quadrant, we have 0.2 right there. And so when we look at finding what theta is, 180 degrees is pi, right? That's all about the radian measure plus another 0.2. So we are going to have pi plus 0.2, which is 3.14 plus 0.2. So I'm going to get 3.34. There's one answer. All right. My second answer, this time I'm going to have to subtract because 2 pi is 360 degrees, but I'm backing it up 0.2. And so theta is going to be 2 pi, which is all the way around the circle, backing it up 0.2. So that's 6.28 minus 0.2, which is going to be 6.08. All right, and so those are our two angles in radian measure to solve our linear equation, which has a trigonometric function inside of it. All right, so again, the start was just rearranging it, so we got sine theta by itself, and then of course we did the same thing, solving a trigonometric equation as we did the other day. Now, example 2, step it up. It gets a little harder here. The reason this one is harder is because we have 3 sine 4 theta plus 2 equals 0. The reason this one's different is I have a 4 theta in there, all right? So anytime you have anything other than a theta or an x, if there's something extra in there, I do a substitution. And so I'm going to let x equal 4 theta. All right, and so I just turned my equation into 4 sine x plus 2 equals 0. Essentially, with that substitution, I made that equation just like my first example. And so I'm going to do it just like my first example, except for the ending's going to be different. And so again, I'm going to move the 2 over to the other side. So I have 3 sine x equals 2, or -2, divided by 3 on both sides. And I have sine x is equal to -2/3. And I copied myself here on the first example. So again, using the cast rule, the only time sine is positive is in the first and second quadrants. So again, our answers have to be in the third and fourth quadrants. All right, I take the sine inverse of 2/3, right? Because the sine just tells me the cast rule. That's all it does. And the sine inverse of 2/3, I get, let's see here, whoops. Sine inverse 2 divided by 3. And I get, rounding to 2 decimal places, 0.73. All right. And so now I look at what x would equal. All right. So I know, again, I know it's got to be down here. And down here is my terminal arms where I have 0.73. And so in this case, just like before, x is going to be 180 degrees plus the 0.73. So I got pi plus 0.73, which is going to equal, let's see here. I get 3.87. Over here, I get x equals 2 pi minus 0.73. So it's going to be a 6.28 minus 0.73. And which I'm getting is 5.55. All right, now, we don't want to know what x equals. We made a substitution. So here's the extra step because we made a substitution, is I have x's for theta. I want to solve for theta. So these two x's, I'm going to resubstitute back in the fact that x is for theta. So I have for theta equals 3.87. And I've got 4 theta is equal to 5.55. And so then I'm just going to divide each side, because again, our whole goal here is to solve for theta. Divide both sides here, or both equations, I'm doing 2 at once here, by 4. And now we solve for theta. So, whoops, divide that by 4, also divide that by 4. So my 2 answers, if I take 3.87 and divide by 4, I'm going to get 0.97. And on the other side, if I get 5.55 divided by 4, it's going to be 1.39. And there we go. So again, the key is we're going to create a trigonometric equation that we can solve just like we did before by rearranging things. But sometimes you have to make a substitution when you just don't have a sine theta or a cos theta or a cos x or a sine x. When it's bigger than that, when it's a 4 theta or a 3 theta or whatever it might be. All right, so that's the first 2. We'll look at example 3. Let's see here. All right, so example 3. Again, just mixing it up to what we've been doing, where we're going to be solving. We have 4 in brackets secant theta, which was one of our reciprocal functions, plus 2 equals 1. All right. So again, what I want to do is get this trigonometric function by itself. All right. So I got to do a little rainbow rule first here. I'm going to multiply the 4 out. All right. So that I have 4 secant theta plus 8 equals 1. All right. Then I'm going to move that 8 over to the other side. All right. So I'm just again getting that secant theta by itself. So I got 4 secant theta. Whoops. Secant theta equals, well, you have 1 minus 8. So it's going to be a minus 7. All right. And then I'm going to divide both sides by 4. So that gets rid of these 4. So now I have secant theta is equal to negative 7 over 4. All right. So I have now got the trigonometric function by itself. But because we're using the cast rule, I wanted as sine, cos, and tan. And again, secant is the reciprocal of cos. And so I'm going to change this to cos theta. Because it's the reciprocal, I flip my ratio. So now I have negative 4 over 7. Didn't change the sign. I'm just changing, just flipping it, the reciprocal. All right, so now we have a trigonomic function that we can solve. Again, the sign tells me in the cast rule where these solutions are going to be. All right, so I have to look where cosine is negative. Well, cosine is positive here and here. So our answer is not going to be in the first quadrant or the fourth quadrant, which means our terminal arm is going to be in the second or the third quadrant. All right, so there's my terminal arm. There's one, and there's the other answer. But now I got to find that acute angle. All right, so I'm going to do the cos inverse of 4/7. Again, the sine was already taken care of because of the cast rule. All right, so I take the inverse of 4, cos inverse 4 divided by 7. Again, make sure your calculator's in radians. 0.96. All right, so that's 0.96. So that's telling me my acute angle is right here, 0.96, and my acute angle is here is 0.96. All right, and now to find my answers, well, we're solving for theta, so there's no substitution. So I have here is 180 degrees, but back it up, 0.96. So one of my answers is going to be theta pi minus 0.96. And so that's 3.14. Subtract 0.96, I'm getting 2.18. So there's one answer. Now the other answer, we're looking at, we have to add 180 degrees, or pi, plus 0.96. So theta is equal to pi plus 0.96. And so I get 3.14. Again, our angles are in radians. So 3.14 plus 0.96, I'm getting 4.1. There we go. So again, just doing a little bit of math to rearrange it, getting our trig function by itself, and then when we have a reciprocal, flipping it so that we are able to use the cast rule because we want our things in terms of sine, cos, and tan. All right, now the last example, which I'm going to change the wording of it because we haven't done graphing, or we are not doing graphing of trig functions, which I know a lot of you are upset about, but we'll get over it. All right, so again, I'm going to rephrase example 4 question. We're going to do a lot of the same math, but again, we haven't been graphing it. All right, so it's we have the high tide in Matthews Cove, New Brunswick is at midnight, which is true. I got this example true. The water level is at a high tide is 7.5 meters. The depth, d of meters of the water in a cove at time t hours is modeled by the equation. So here we got our equation. D equals 3.5 cos pi by t times t divided by 6 plus 4. All right, there's our equation. Jenny is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver her sailboat. At what times will it be safe for her to sail to Matthews Cove? Here's how I'm going to change this question for tests and quizzes, because we didn't do graphing, is that I'm going to ask you, when would the water be 2 meters deep? All right, that's what I'm going to ask. When is it 2 meters deep? So that means our D value we're looking for is 2. At what time is the water 2 meters deep? Now, here's the thing with this question. Look inside our trig function. It's not just one simple thing. It's just not a t. We got pi by 6 times t. So I'm going to make a substitution. I'm going to let that whole thing equal x. So I'm going to let x equal pi times t divided by 6. All right, so now our equation becomes d equals 3.5 cos x plus 4. All right, then we can resubstitute it in after like we would do before. Now we're looking, when is the water at a depth of 2? Right, depth of 2, so I substitute 2 in for d. So I got 2 equals 3.5 cos x plus 4. All right, so we've made a substitution. And now what I'm going to do is, well, get my trig function by itself. That's the whole goal today, and then solve from there. And then we're going to have to resubstitute. So I'm going to bring this 4 over to the other side. So I'm going to have a 2 minus 4, so that'll be a negative 2. All right, I still don't have my function by itself, so I'm going to divide both sides by 3.5 equals cos x over here. Negative 2 divided by 3.5. I have no idea. Let me see here. I got negative 0.57. All right, so we got negative 0.57. So again, when I look at my solutions, possible. Well, when is cos negative? Look, it's positive in the first and fourth quadrants. So those are gone. So again, it's got to be in the second or third, right? So now to find my acute angle, I do cos inverse of 0.57. Again, the sign just telling me what quadrants my answers are going to be in. So I get my acute angle here. So I go cos inverse 0.57, and I'm getting 0.96. All right, so 0.96. All right, so now I know that I got one terminal arm right here, the other terminal arm right here, and I got a 0.96 right there, and I have a 0.96 right there. So again, to find x, because that's what we're solving for right now, I got 180 degrees all the way, back it up 0.96. So I got pi subtract 0.96, which would be, let's see here, pi 3.14, subtract 0.96, 2.18. There's one answer so far. All right, and then again, just like we did before, pi 180 degrees turn plus a 0.96. And let's see here. So we take, 3.14 plus 0.96. We get 4.1. But in this question, we want to know what t is, how much time's gone by. So this is where I resubstitute again. All right, so the x, we've got two x values, but all of them equal pi times t divided by 6. So I'm going to have pi times t divided by 6 is equal to 2.18. That's one equation I'm going to have to solve to find my time. And the other one would be pi times t divided by 6 equals 4.1. All right, and solving the first equation here. Again, I'm running out of room, so I'm going to go a little quick. I'm going to multiply both sides by 6. That'll get rid of those 6's. And then I have to divide both sides by pi. Because that'll get rid of those pi. And I'll get my t by itself. And so my time, 2.18 times 6 divided by 3.14. So I get 2.18 times 6 and then divide by 3.14. And I get 4.17 hours. All right, do the same thing over on the other side here for our second equation. So I'm going to multiply this side by 6, divide by pi, and that'll get rid of both of those. And I get my t value time. So we want to know when this thing is at a height of 2 meters. So let's check it out. We got 4.1 times 6 divided by 3.14. And I get 7.83 hours. So the answer to this revised question is, when is this water level at a height of 4 meters? Or sorry, 2 meters? Well, after, and this is at noon or midnight, 4.17 hours after midnight, and also 7.83 hours after midnight. And that's when the water will be at a height of 2 meters. Again, I switched the question because we didn't do graphing. We didn't get to that.